So let us start with a basic understanding of what we call as motion. Fine. Now, in this chapter of motion, the first thing that we are going to understand is basically types of quantities. Okay, and then we will move forward. Okay, and we'll understand what exactly is distance, displacement, speed, velocity, and acceleration. At any point of time, if you think you have not understood something, pause the video, go back and see again. You don't understand it yet, put it in a comment and I'll try to explain it again. Okay? So let's begin with types of quantities. Now you see, when we say types of quantities, there are basically two types of quantities. The first one is called a scalar quantity and the other one is called a vector quantity. Let's take an example. The example of your height. Fine. Now let us suppose that you are standing. This is you. Okay. So let us suppose that you're standing and I take a scale and measure it. Fine. Let us suppose that now you lie down on a floor. I take a scale and I measure it again. So let us say the measurement here is L1 and the measurement here is L2. Now tell me one thing. Do you really think that L1 will be any different from L2? Shouldn't be, isn't it? They will not be. You are, when you're measuring L1, you are pointed, let us say, in the upward direction. When you're measuring your length again, but in the L2 position, you are, let us say, towards the left hand side direction. But this directionality is not going to affect your height or the length of your height, whatever. That means your height is independent of direction. So direction has nothing to do with your height. All that matters is the magnitude. So any quantity in which only the magnitude matters and not the direction is called a scalar quantity. There are other examples. For example, temperature. It's a scalar quantity. As you will see later, speed is a scalar quantity. Your mass is a scalar quantity. Fine. Now, let us look at what is a vector quantity. Fine. Imagine you are standing near your house. On the western side, so we have the north, south, east and west. Fine. So on the western side of your home, about 100 meters, there is a shop. Whereas on the eastern side, again at a distance of 100 meters, let us say that there is a playground. Now somebody has come to your home and wants to go to the playground. If you just tell the person the playground is 100 meters from my home, is that enough information for the person to reach the playground? Possibly not. Because the 100 meters can be towards the west, it can be towards the east. So if you want to tell the person that, see, you have to go 100 meters towards east to reach the playground, then that is a complete description, isn't it? Now remember, what you have told here is nothing but distance along with direction. So when you're talking about a quantity where just the magnitude is not going to be enough, you have to give the direction also. These kind of quantities are called vector quantities. For example, displacement, as you will see later, weight, force, and a plethora of other quantities. These are called vector quantities. So, what is a scalar quantity? A quantity where only the magnitude is enough. And what is a vector quantity? Where along with the magnitude, you have to specify the direction also. Fine? Now, let us move on to the next topic. What is the next topic? Distance and displacement. Distance and displacement. Let us say we have 2 points, A and B. Now I ask you to go from point A to point B. Well, you can go like this. You can go like this. You can go like this. There are almost infinite possibilities for you to reach from point A to point B. Each of these possibilities, 1, 2, and 3, they have different path length. So the path length is different. So if you have different path length, this quantity is called a distance. So what is distance? Distance is the total length of the path you take to go from point A to point B. Now imagine you go straight. You don't go in any direction. You just go from point A to point B in a straight line. So whereas the path 1, 2, and 3, as we have just now seen, can be anything in any direction. It can be wriggly, it can be like an arc, it can be anything. But when you are going from point A to point B in a straight line, this becomes the shortest distance. The shortest path that you're taking to go from point A to point B is a straight line. And this shortest straight line distance is called a displacement. So what is a distance? A distance is the length or the total length of the path that you're covering. What is displacement? It is also a length of path covered, but the main difference is it's the shortest length, and hence it's a straight line. It goes from point A to point B. And another important feature is, whereas distance, you can see from path 1, 2, and 3, that there is no directionality involved. But when you are going to say about displacement, what you would say? The displacement is point A to point B. Similarly, if you're going back from point B to point A, then we call it the displacement is BA. So you're going from A to B, you have to mention a direction. You're going from B to A, it involves a direction. So, whereas displacement has no directionality is involved, uh, pardon me, whereas distance has no directionality involved, displacement has a direction. So, there are two important points here. One, there are infinite possibilities of distances, but there is only one possibility of displacement, and that displacement possibility is a straight line going from point A to point B. Okay? Now, let us move on to the next point. Let us say a person starts from point A, goes to point B, and then moves on to point C. So, the distance between A and B is, let us say, 3 meters. And the distance between B and C, let us say, is 4 meters. So, the question is, what is the distance and what is the displacement? So, distance, remember, is the total path length. That means from A to B plus from B to C. So, A to B is 3 meters, B to C is 4 meters, that makes it 7 meters. Now, what is displacement? It is the straight line path between A and B. So, what is a straight line path? If you join these 2 points directly, we've got a straight line path. Now, just for the sake of simplicity, I have made these points in such a way that we have a 90-degree angle here, which makes AC the hypotenuse of a Pythagorean triangle. So we can calculate AC. How? It will be under root of AB square plus BC square. So what is AB square? 3 square plus 4 square. This makes it 9 plus 16, which equals 25 rooted, and we get 5 as the answer. Which means the straight path from A to B to C is actually a straight line called AC, which is equal to 5 meter. Now this brings us to another very interesting conclusion. Displacement is either equal to or less than distance. Displacement can never ever be more than distance. It will always be at the max equal to or always, almost always less than distance. Fine. We'll do some more questions trying to understand what is distance and displacement. So that's all for today. Okay. Tune in for the next video on speed, velocity, and acceleration. Bye everyone.